Good afternoon, viewers. My name is Akinwelu. Today we'll be looking at the Pinhole camera, and under it we are going to consider magnification. Now remember that firstly, when we talk about the pinhole camera is a simple device that has a small hole in front of it used for forming an inverted image of an object. And you know, part of the properties of it is that the smaller the size of the hole in front of the pinhole camera, the brighter the image formed, the sharper the image is, but it becomes dimmer. But when the hole is large, you are going to be having a brighter image, but it will be blurred. But today we want to look at the magnification, and we are going to use it to solve question on it. Now the magnification of a pinhole camera can be given as m equals image height over object height equals image distance from pinhole over object distance from pinhole, and which can also be equals to the length of camera over object distance from pinhole. So any of these formulas can be used to solve the magnification of a pinhole camera. Now let's consider the question which we have here. A boy 1.5 meter tall stands 2.0 meter in front of a pinhole camera of length 20.0 centimeter. Calculate the height of his image. Now let's bring out our parameters from here and see what we are asked to solve. So we'll look at which of the formulas are we going to apply. So solution. So already in this place we are told that a boy 1.5 meter tall. So this is the height of the ball, the object height rather, which is the height of the ball, because they say a boy 1.5 meter tall, so the boy is the object, so his height is 1.5 meter tall. So I'll say object height equals 1.5 meter, stands 2.0 meter in front of a pinhole, and that will be the object distance from the pinhole. Object distance from the pinhole. From pinhole equals 2.0 meters. In front of a pinhole camera of length 20.0 centimeters. So the length of the camera itself is 20.0 centimeters. So camera length. So if you look at something very well, you will discover that the object height and the object distance, which is the boy, the units are given in meters, but for the camera length we are having it in centimeters. So when you convert from centimeters to meters, we divide by 100. So 20.0 over 100 meters, and that will give us what, 0.2 meters, so that the units can be uniform. Then we also calculate the height of his image. So we are looking for the image height of the boy. So the formula we are going to apply. So image height is what we are looking for. So we are going to apply magnification equals image height divided by object height equals length of camera divided by object distance from pinhole. So let's slot in our parameters. So our image height is what we are looking for. So let's put that the image height. Now the object height we have is 1.5 meters equals length of the camera. We've been able to convert to meters, 0.2. Object distance from pinhole we are giving us was 2.0. So let's cross multiply. Well, cross multiply our image height becomes, this goes with this, 0.2 times 1.5 divided by 2.0. So let's finish it up here. So 0.2 times 1.5, that will actually give to us what? 0.2 times 1.5. Let's look at that. This is 10, 1, 2, 0, and that will give us 0.3 divided by 2.0. So therefore our image height so we have 0.3 divided by 0.2. If you are to take that, 0.3 divided by 2, if I make this 3 over 20, that should be 0.1. I'm left with 10, so I should have it as 0.15 meters. So that should be the image height of the object. So thank you very much.